Okay, so this is a local shop here, and they had solar panels fitted. They haven't got a clue. Electricians have sold them stuff. It can power these lights. That's all it does. That's what it's doing. And they did have a really good inverter before they got this solar. They got this inverter, it's about 1.7. They had a 3 kilowatt one that blew up. And what you'll see here, right, is this is a set of LiFePO cells, isn't it? Lithium, ferrous oxide, whatever it is, LiFePOs. 3.2 volt ones. I can't remember the name of them. Anything else? Right. So you've got this 24 volt system, right? And what you'll notice here, look, there's no BMS. So what happens is, this is charging the battery at the moment because it's got built-in charge to hybrid. Right? So it's charged at 26.3 volts. Yeah. AC input nothing. Output 220 volts. Yeah. Okay. Doesn't say what the putting in 300 watts in the cells, what have you. That's not the point. The point is, right, there's no BMS. You just saw there it's giving 26, he puts 26 volts down, charging these, as well as, and then these lights are probably getting some power as well. I think those lights are plugged into here, right? That's if they are. Are they even plugged in? There's nothing plugged in. I don't think nothing plugged in. But, so, right, this, the 26 volts comes down and charges this with 26 volts, this 24 volt system, right? It's fine, but the thing is, if one of these cells, when you take the cell voltages, this is what I've learned, you take the cell voltages individually, one of these could be at, say, 4.5 volts, you know what I mean? And so, what the other ones could be low. What you should be doing is shutting down. If the whole lot, if one of these cells goes high, you're supposed to have it's supposed to have a BMS with a pos and neg. That was the arm bit so close to. With a pos and neg. So you'll have, so for this here there's 8 cells. So you'll have 8 sets of pos negs coming down and going. Actually no it won't. You'll have one negative. Sorry, you'll have one negative going to the negative point here, which is what's there here. Right, that's the start. Then all the rest of all the positives. Right, so if that's a positive. And is that a positive? And is that a positive? You'll have all the other, so you'll have number 1 will go to there, and then all the other 7 ones will go to each one of those, and it takes the voltage of each one of the cells. If ever one of those cells goes high to the point where it could be boom, where it can explode. That's why they've got all these straps around. They think, I mean, to strap them together. This is just a local electrician or a guy who's doing this, right? For people, he doesn't know what he's doing at all. He's just rigging it up, you know. So he's supposed to have is when he looks at the positives of every one of them, and then they've got the reference negative. If one of these goes high, it shuts the inside the battery, inside the BMS. There's a semiconductor switch, right? And you just bump in open circuits, and then basically these can't get charged anymore. You also can't give anything out. So when in a situation where, say, at night, or when there's a power cut and this light is now discharging, because nothing can charge because there's no sun. So when it's discharging now, also the battery management, the BMS, battery management system, right? Well, I don't know what it stands for. It's a BMS, battery management S, I don't know. What it does, it's also looking at them again, because as they all go down in voltage, right? What you don't want is one of them to go any lower than, I think it's something like a 3.2 volt one would go no lower than 2.5, say, for instance, right? If one of these goes lower than 2.5, then the battery management system again will shut off and it will stop. It's in the negative. The switch is in the negative, so the negative will shut off, and then basically that can't send any power out. Then you know you've got a problem. But basically there's nothing like that here. So this can overcharge one of the cells, and they all change. Some days it'll be that one, then some days it'll be another one. Or when they go really low, all the other ones are great. They're all like say 3.5 volts or something as they're going down, because they get charged up to 3.2 3.75, something like that. As they're going down, as they're being discharged in use in a power cut, you get all of them stay round about the same, like say 3.2 volts or something, or 3 volts. One of them could go all the way down to 1.8 volts. That's the moment they should shut everything down and say we've got a problem and call somebody in, because one of the cells is faulty, or it's not holding its charge anymore because it's got no capacity. Because they're supposed to hold 100 amp hours of each one. These are 100 amp hour. They're supposed to hold 100 amp hours, but sometimes one of them might be just knackered, and it basically can only hold 70. When it charged up, it can only hold 70 amp hours. So what happens is it basically fails earlier, right? Now, there are things to get around that called flying capacitors, which I think are brilliant. I've got them on all my battery sets. And what you do is you have this device. It's got a lot of capacitors in it. And what it does, you connect them. You connect this device with another ribbon cable that goes to every one of them. And then as the voltage goes down, right, what it starts doing, if you've got, let's say 90% of this lot has got volts enough, and one of them's dying quick, all of these ones will give its voltage to that one. And similarly, if one of them's charging up too quick, right, because it's got less capacity, so all the other ones are charging at a steady rate, but one of them, it's got no less capacity. So what it does, it ends up charging up too quick because it fills up. It's like, imagine having all of these are all glasses and you're filling up with water, but one of them you've stuck a big stone in the bottom of the glass, so now there's less capacity in the glass, so as the water could fill up quicker and it starts going over the top. So what would happen is, as it's going over the top, so to speak, if it was a glass with water entering it, it would just fill over the top and start charging all the other ones up. So it does the opposite of when it's going down, you know what I mean? And it's called flying capacitors, and they're great, and I've got all of them. I've got those on all my cases, and I never have. Then the BMS never trips, right? So you need a BMS and you need a flying capacitors, but at least you need a flying. If you've got a flying capacitors, you never hardly ever. But the thing is, the flying capacitor it's like I can't think of the bloody word for it now, but it's sort of like a balancer. What it will do, if it continues to work, it will allow these to always be charged equally, right, or discharged equally, yeah. And that's it. And this is the problem we've got here. But I've tried to tell her, you know, I can do it for him. All I've got to do is fit it in here, and then fit one of the wires that comes off it. There's 9 wires or 8 wires, one onto there for the negative, and then all the positives of each one, just put one onto there with just a crimp, and that's it. He just looks at them all, and it'll just shut the whole lot down. But then you think, well, when it does shut down, because these will have a problem, because unless you get a flying capacitor, unless you get a flying capacitors module that basically allows it to discharge and charge up equally, right, in the way that I've just described, it will trip, because these are second-hand batteries, second-hand cells, you know what I mean? And even new cells, they always charge. You always get one. Even brand new ones, you'll get one that charges up more than the other, so it'll hit the height. And also, the sum of all the 8 cells gets to over a certain amount, right, what it'll do, it'll shut it off early. So you might have one that charges up because it's only got 50% capacity left, so it charges up to its 3.7 volts or whatever so quick. You add that 3.7 onto what all the other ones could be at, say 3, as they're charging up. You add that all up, and it actually meets the overall target for tripping it as well. And that's why you've got to have a flying capacitors. But say they're not utilising this enough. Even when they have a power cut, it doesn't even work. It's crazy what they're doing here, but they're not the cleverest. There we go. That's the setup down at this shop, my local shop in Thailand, in the village.